Hi, okay, this is Professor Benson recording how to do the demand exercise. Now note, over here I have actually changed the the quantity. So the numbers that I get at each point in this tutorial will not match, will not match what you get when you do yours. So I just want to make sure that when you see that your numbers don't match, you don't you just recognize that that's why. I've changed these numbers because I don't want people just copying down numbers. I want them to actually have to do it. But so first you're going to, the exercise asks you to plot a demand function here, and just remember, as I say here with number one, is that quantity must be on the y-axis. So when you do it, Excel is going to first default to have quantity here on the x-axis, and you actually need to change it so that it's over here and that you've got ticket price here on the x-axis. And then to be able to fit a line to this, you add a trend line. So you right click and add a trend line, and you want to do a polynomial. We want to display the equation. I'm going to make this a little bit prettier. Okay, but that's the formula that I come up with right here. So that's the formula I come up with right here. That y equals 2,219 x squared minus 14,471. Let's see. I'm going to add the sorry, I want to have just one decimal place. Okay, so down here what it says is estimate the demand formula for the demand curve. And essentially all you need to do is take this formula that you get up here, I'm going to bold it and make it a little bit bigger. You just need to take that formula and put it down here, and just remember that the y variable here is quantity demanded and the x variable is price. So this is the demand function that you get. Then using that formula that you found here, it asks you to forecast how many tickets would you sell at different prices: $2, $1, 50 cents, and 0. So all you do is you plop in, just make sure that the formula there is the same as the formula you have here, and then remember that anytime you see an x or an x squared, you're actually going to be pointing it over here at the price, because that's the x. Okay, so then it asks you to compute the demand elasticity at 4 price points. And to do that, you're just going to move in penny increments, so 50 cents to 51 cents, $1 to $1. So you're going to, again, use the formula that you derived up here. You're going to move in these increments, and then remember that when calculating elasticity, you always want to use new minus old divided by old. So new minus old divided by old. So that's the formula I have here. And so you get an elasticity there of negative 0.29, negative 0.66, negative 1.09, and negative 1.51. Remember, elasticity, own price elasticity is always negative. Okay, so I put up here are these elastic or inelastic, and I put it here at each of these points. All I ask you down here is to say if the theater were charging $1. And they raise prices, would you expect revenue to increase or decrease? Well, we would expect it to increase because this is less than 1, and so it's inelastic, which means people at that price are price insensitive, so you could raise the price and you would do better. And then it asks you, in which range do you expect the revenue maximizing price to fall? Well, we would expect it to fall here somewhere between $1 and $1.50, because that's when it flips to be from being less than $1 to more than 1. And in fact, I just put down here in this particular case, it looks like it'll be fairly close to $1.50 just because the elasticity is so close to 1 there. And then so this implies that the price is inelastic at $1. So to use solver. So we're gonna find this point 3 different ways, that revenue maximizing price. So the first one is, so we've got price here, here's quantity. Okay, here's quantity. Remember, you have to point it at price, so that as we change price, the value here in the quantity cell is changing, and then revenue is just price times quantity. I've set it here at $1 just to give it a place to start. So here you do on data, solver, okay? Now, set objective. So what we want to do is maximize revenue. So we want to maximize this guy by changing, in this case we want to change price. So by changing price, so B92, okay? We're not going to add any constraints on this one. You can leave the rest of this as is, and then you just hit solve. Solver does its magic, and you come up with $1.40. In fact, it's not $1.40, it's $1, this 16 digits, $1.3994, okay? In 7B, what I say is, okay, well, take some points around the price you find here. So in this case, I'm saying $1.40. You should find $1.32 if you've done it correctly. And what you're going to do, I don't need this to be, is just move in penny increments around. So I just did 5 cents below and 5 cents above. And so you plot quantity, I'm doing the revenue, and you'll notice here that revenue is, as I increase price, it's increasing till I get to here, and then now as I go from $1 to $1.41, it decreases and then on the way down. So all I do is calculate elasticity here at this point, and lo and behold, it's -1. And then the other thing, but what I wanted you to see here was that if you've done it right up here, you should get the same value right there. And this won't be, I've done it to 2 decimal places. If I take it to more, it's not exactly -1, and that's because this isn't exactly $1.40. It's $3.99. Okay, now using calculus. So if this were my demand function, so I've chosen a different one here, but just to walk you through the math. So what I want you to do is we should find that elasticity using calculus should be -1 at $1.40 if we've done this correctly. Remember that the formula for elasticity is d cubed dp, so the derivative with respect to p, times price over quantity. So if the demand function that I estimated was this guy right here, 29.6p squared, and so on. So it turns out that the revenue maximizing price for that function is $1.73, and at $1.73 we would sell 251.2 units. Okay? So the derivative of dqdp of this guy right there is 59.2p minus 248.6. And if I plug in, since I've still got this p there, when I plug in $1.73, this whole thing equals -146.184. So dqdp right there. Then I do, remember it's price over quantity, and so price over quantity, and so we've got it's $1.73 and it's 251.2, and lo and behold, when I multiply them together, I get -1. So you should get, if I did it for this function here, I would get $1.40 all 3 places. I would get it here. We would get it here with solver, we would get it here, and we would get it, when we multiply this all together, you would get, hey, the derivative's -1, I mean not the derivative, the elasticity is -1, which means we are at the revenue maximizing point. Okay, thank you, good luck.